this. And I wanted to bring up the final project proposals because technically yesterday was Monday of week 10, so we'll extend the deadline for this to Monday of week 11, which is next Monday. I'm not going to go through the entire document again. We did that. You can review the video, or I think it's relatively clear what I'm expecting of you by that deadline. It's going to be a write-up in which you're discussing the big picture project idea, what you want to accomplish, and more importantly, in terms of how it will get evaluated at the end, is that grading rubric, your own rubric that you'll use to self-assess. And you'll also have peer assessment, also instructor assessment of what a successful version of your particular project is going to look like. So that's due 6 days from now, whatever you want to describe it. We're going to talk about it in class next Tuesday with a Canvas submission beforehand. I won't ask you to come up here and give presentations, but please come to class next Tuesday and I'll ask you questions about it. I'll bring up your submissions and I'll just kind of review them. I'll hopefully have a chance to look at them the night before, if not then the morning of, and then we'll review them in class together. And then I'll give you more formal feedback in Canvas itself. If I want you to revise and resubmit, I'll ask you to do so at that point. I think the most likely outcome for any of those will be, I'll say, project idea is great, tweak this part of the rubric and you can go, and that will be fine. But this does take work. I already said that several times. I don't want to sound like a broken record here. It does take work to create a good rubric because it does require thought. You can't just, it's not a creative writing exercise. You can't just come up with something and expect it to make sense. You have to actually do a little bit of that groundwork to know for this particular idea, what concrete steps is it going to take? What is the approximate estimate of difficulty or time it's going to take? And then consequently, what is beginning, accomplished, and exemplary for that component of the project. So my suggestion for your workflow for this week, first off, 6 days is more than enough time. Assuming you've had at least one conversation as a group at a high level about what kind of project you may want to work on, is that you can kind of split the team up a little bit this week. So certainly you dive into MP-4, take a look at what that involves. It's a kind of a direct continuation of MP-3, so I understand that for those of you whose Vertex shader isn't quite perfect, you may find yourself still fixing some of those bugs, and that's expected and okay for MP-4. But then in parallel to that, whether the group is split in half, whether one person carves out and starts thinking about this more deeply, you start to do that work. Do it Wednesday if you need to. If that's the one time you're all guaranteed to be together in lab at any given time on that Wednesday section, or just separately discuss online or in person what your project's going to be about. Post some ideas of what you may want to work on, post any questions you may have about this, but get this done by Monday and submit it so that we can discuss in class on Tuesday. You'll still be finishing up MP-4, but that gives me a few days to kind of review it formally and provide that formal kind of green light to go forward. But pretty soon you're going to be jumping into that. So MP-4 is a relatively direct continuation of MP-3, and then everyone's going to kind of be working on different things. And so the scope should be as if you're doing another MP assignment effectively, but it's one in which you're not given that direct guidance. There is no MP5 assignment that you're following. You are instead kind of, in a sense, making your own MP assignment. The write-up doesn't require you write it up like it's a lab assignment, but you have to be thinking of it in those terms, certainly in terms of scope of what you can accomplish, certainly in terms of breaking it down in terms of what logical steps are required, what is the game plan, what is the timeline, the schedule to get that done. We may do sort of an informal status update in class between now and the end of the semester. I've thought about having slides and have you presenting that, but I think just a go-around may be sufficient for that. But then during our final exam time slot, we'll use that entire time for our final demo day for that, and that's when everything is due for the project. So before we jump into MP3 demo day, any final questions about this assignment? It's good to see some faces I haven't seen in a while. Let's go ahead and get started with group number 4. Brandon, Will, James. James, you're on the hook for explaining what it means to have exploded.
Yes, our poor buddy James is unbelievably sick.
Still ill.
Yes.
Okay. You can cover for it.
I sure hope so.
Okay.
So I'm Will. I worked on the first go at the shader hardware implementation.
And I did most of the driver work, and then
And
we both did debugging.
Yeah, we basically met up and sat together and worked through the debugs. As for the hardware for the Vertex shader, I'm assuming everyone's is going to look pretty similar. But basically, we just kind of, when the vertex's start is high, go to fetch, wait for IMEM ready, go to fetch to, I'm missing a label there, but it's when the IMEM request done, then we move on to decode. Inside decode, all it really does is check if the opcode is done or no op, and goes back to wait to start, or just increments the PC by 4. And that's all it does. It's just kind of a blank spot, and then we jump down to execute if it's not one of those 2 opcodes, where we go through a giant case statement comparing all of the fun opcodes, and that all goes to D to V, which is like my placeholder. Within execute, we have just the generic D array. What's that called? Array vector, whatever the vertex array object is. And in D to V, all that does is push it back into, writes it back to the register file, and then increments by 4 and goes back to fetch, with the exception of load and store, which need those extra steps for the memory handshake. And there's one more that I didn't put here, but when we do out FIFO, it skips the D to V step because we were having a bug. Well, I guess it's not a bug, it's intended to work that way, but if you write back to the after doing out FIFO, you are writing the address to a space that doesn't exist. Or I guess the other way around, you're writing information that doesn't exist to an address at the register, because the out FIFO opcode takes the destination address as a literal number rather than a
Yeah, and I think lots of valid opinions about whether in FIFO or out FIFO are correctly constructed, but at least it's correct in terms of the documentation. So if you implement within the documentation, it will work. It's just not the most efficient way of doing things.
Yes.
You did all of your execution for like arithmetic in one state.
Yeah.
Did you have a critical path issues by the end?
The very first run through, the very first version that I wrote that just had the opcodes listed in the, I can't remember how many it is, the first 8 or the first 10 opcodes that were written in there. That I got through with no, it was like perfect timing, like 0.04 negative slack. And then after everything, now it's like -5 or -6, so I probably need to.
And I think that's, so decode does the register reading, and then you may just want to split it up into multiple cycles for the execute, which kind of defeats the purpose, obviously, of having like this SIMD organization if you're going to split it up anyway. But that's what I've seen, that it struggles.
It's
to
too
do
much.
Multiplications in parallel.
I gotcha. Yeah, that's probably what needs to happen.
And then for driver changes, we had to add a couple functions, and the most important part that took us a while to figure out was the bottom one there, adding that right to the vertex shader num vertex. We were getting some weird flickering issues without that, and we thought it might have been cache until I was looking through the VHDL for the SGP vertex and noticed it was reading a register that we weren't setting anywhere. And then after I added that, I had forgotten the -1 because for the vertex fetch unit, you weren't having to do that because it was done in hardware, but not in the vertex shader unit. So
this is how it generates the TLAST signal by again kind of counting down how many vertices it's supposed to process. That's probably not correct in terms of like logically how you would normally do it. You should be able to propagate the TLAST signal, but if this works and it's simple, then it's fine too.
Mm-hmm.
You wouldn't be able to do it for last fragment, right? Because you don't know how many fragments.
then as for testing, we didn't actually like get far enough to use the simulator to go through each opcode to make sure everything was working properly. Most of what we were doing was bug fixing our color because we fixed it for 5 minutes and I don't know what we did because it's broken again. So even going through old commits, can't figure out what got changed. So that's what we spend most of our time on. I think, fingers crossed, the position and everything works just fine for the shader, Vertex shader hardware. So I think we are in agreement that the color is outside of the Vertex shader as the problem. I think once we figure that color out, it's literally going to be double check that my F multiply and F add are doing negatives properly, and then everything will just work like magic. At least that's the dream, right? And then we can actually go through and simulate and test everybody.
Another thing to consider is I don't think that hook is in there right now would be to add back like a pass-through, like a hardware pass-through Vertex shader where you set a register just for testing purposes, I guess, to say, well, if I'm trying to isolate the bug, just set that register and just pass input 5, physically pass input 5 foot, output 5 foot, then you can tell if something else is there.
Did that last night actually, like this morning or whatever time of night it was. I did that pass through where it was output is set to input and just commented out all the other out FIFO stuff. And when I ran it, the color was still messed up. That's sort of my claim that it's outside of the.
We've been somehow carrying forward this color bug for several weeks, and we can't figure out why it keeps coming back, because we fix it, and then we change something, and it comes right back. And
Yeah, we add a new block, and then it's returned. I love these bugs. I think these are hilarious. Let's see if they'll play. They weren't playing yesterday. So what you'll see, kind of funny, is that
Is that like just one line of it? So
X position is working perfectly, but the Y position just doesn't exist. And so you can see as I drag around the points, it's like it's getting squashed down flat. And then if you play the second one, this was a terrifying thing that we saw happen all of a sudden, is that when you change the color on one of the points, it gains Y. So
somebody else too. Which other team did that?
I think it's an out FIFO issue.
Yes.
Or in 5 or out 5 against, right?
Correct. Yes, we did figure that out after changing about 1 million things and then just reading through line by line the assembly, that we were rewriting register 5 over and over again.
Really cool looking bug though. You show me
Right?
the right hand side where you're changing the color
Mm-hmm.
and it's causing the geometry to change.
Yep.
And it just so happens to work because it's like normalized color values that correspond to a valid X or Y coordinate location.
Yes, and it's only the green because that's Y. It was very frustrating, but kind of comedic at the time.
Well, it's only the green because that's the Y.
Yeah, and then our color bug shown in the middle, I guess, with it's only showing yellow for some reason.
What color should that part be? Do you remember?
That is red at the top, going down to green at the right.
Yeah, but it's like a constant yellow. So
I know, right? There's no.
we fixed that last MP, and I think it was something to do with C5, C6, but we went through and it should be fine, so we're not quite sure what else could be wrong.
And then here's a little bit more in-depth examples of what's going on with the color. Top left, you can see that when we change all the vertexes, so the bottom two are full red and the top one is full blue, it gives the whole thing that magenta full color, like it just doesn't want to do the gradient at all, or if like each point is just adding the colors together.
Yeah, so it's rasterize. It's rasterize, or whether it's set up, and that for better or for worse, that is. I mean, when you have time, that is testable. Just kind of go back and go back to paper and pencil of what those values should be and see if it's generating values that make sense.
Top middle is the triangle shapeshifter one. When we run it on the screen, obviously it bounces around and works just fine, but on our hardware output, we just get a stationary triangle in the middle. I think Andrew mentioned it was probably something about cache needs to be wiped or cleared before the next cycle. So maybe we could look at that. I don't know.
One way you can confirm that, I think, would be to change the software application to have a different value to start with. I don't know what value it starts with, but change it and see if it does look different, and then if it's still static, I think cache is the most likely. And one team just got rid of the cache. Which team just turned off the
I
cache?
put it back in.
Oh, you did? Okay. I mean, it could be, from a performance perspective, not that meaningful. I don't know how much slower it was to not have it,
It
but
should be like, in my mind, it should be like 4 times faster if you're doing block things, if you're doing like 4 uniforms.
but then there's all the other instructions, so you know that might still take more time than
Mm-hmm.
fetching those 4 values.
And from my vague understanding of viewport, that red triangle on the hardware output is roughly where it should be if it's not being scaled at all. So like our scalars are just all 1.
Yeah, so testing with scaling 1 doesn't really test all that well, so I would just
Okay.
change it to 2.5 or something, and then if it is scaled, it's probably okay. Then it's just
I gotcha.
a cache issue.
And then similar with the cube flyby, you can see our color, it's just all giant triangles that take up the whole screen. They're white because our color doesn't work. So I can't really tell, but you can tell that the MVP doesn't work at all. So I think that's my F multiply or add, just not happy in any way. And then I think that bottom photo is after I redid pass-through maybe? I don't remember what I did.
It was passed through, yeah.
So it's just showing that it's the same problem even with pass-through, so it's just screwed up color somewhere else. I think that's it.
But questions for group 4?
I just have a couple comments. So for the big thing on the top right, it's probably big because you don't have a division implemented, and it uses
Okay.
a perspective view, which uses division. So if you have division as a pass-through, things are going to be really big.
Okay.
So you can change the driver code to be orthographic, so it kind of gets a nice looking thing.
That's good to know. I
So-
definitely don't have
We
division.
looked at that as a valid question. We looked at that in class the other day, and I thought it was doing an orthographic view already, or maybe the version I had in class was different than what was provided for MP3. It's possible.
Perspective.
It was GLM perspective, not GLM ortho. Yeah, we definitely changed it back to GLM ortho. And that's how it was in class, but I must have already changed it. So that would make a very big difference there too.
Sure.
And we haven't covered that yet. So starting Thursday. Awesome. Way to go, especially for just the 2 of you. It sounds like for this lab with an
Yes.
exploded
Yes.
teammate who I certainly hope gets better.
I
soon.
know, me too.
Hey, way to go. You made really great progress on this. All right, group number 1, come on up.
It seems like Gotham might have exploded too.
Okay. Messed with VHDL a little bit is what he did. Okay.
Yeah. He helped a lot with debugging, so yeah, but I kind of made the first draft VHDL for our shader core, and it ended up having a lot of problems, but we went through and fixed them.
Since I was sick for most of the lab, I was just mostly moral support at the end, and I reviewed some of the code.
Yeah. And then Gotham was helping me kind of debug the VHDL, and he did a lot of the driver code changes we needed. So I can talk about our vertex shader. So I kind of did both level FSMs in this diagram. So like the top level vertex shader is managing the vertex in and out, axis string, handshake kind of stuff, which was provided to us. And then the vertex shader core, we had pretty similar to the way group 4 did it, at least to start. So we have 2 fetch stages to handle the instruction memory weight. Our decode also, it just detects like a done opcode or a no op, and then goes back to either fetch or wait to start. Our execute stage has a a big case statement also, and then for some of the instructions, so like for load and store, it has an extra state because it has to do kind of that handshake with the cache, and then a bunch of the other instructions, I kind of have placeholder states for them, where I knew it would either need to like access some other piece of hardware that I would need to wait for, or if it's like a more complex instruction, break it into different states. So like for F multiply, I ended up in our current implementation, it's still all in execute, but we had a lot of timing errors. It was like minus 300 or something nanoseconds. So I'm thinking we might split that up also later on. But that's kind of the.
It's a really nice diagram, and I really like the placeholder approach, because I think for like fdiv or something like that, at the very least you can just pass through the input or something for fdiv.
Yeah.
So at least the code will execute. It just won't give you results, but it's at least it'll give you numeric answers that make sense if you just do a pass through, and then adding things is kind of a nice step-by-step process.
So that's the plan. And then we did add, it's not in this diagram, but we were trying to mess around with like the cache flushing and things. So we just added a register in the top level that we could write with the driver to kind of have more control over that. Yeah, and so for the driver code, let me see what was here. Yeah, so this is us trying to do the cache flush versus invalidate. I think we were a little bit confused on which one we should be using, because we tried using invalidate first, and then we were having issues where like the triangle was still stationary, and we thought it was cache. That was the problem. So I think we'll probably try changing like the starting scaling, like you mentioned for the last group, next to see if we can get that.
I mean, either is technically potentially valid, right? Normally, flush refers to expunging all the contents of anything that's been updated in the cache. But since you're not, since we're not writing anything, we're not storing a lot from our programs. We're not. Oh no, you have to do both. I guess,
Yeah,
right?
yeah.
So, but invalidating would be assuming everything in the cache is run on refetch. So
Okay.
you really have to do both. The flushing. Well, let's look at the logic for it. Flushing should also invalidate things.
Okay. Yeah.
Resetting the cache, essentially.
And I don't know if he put in the uniform functions here, but like for the uniform for FV and like matrix for FV, we pretty much copied a lot of what was in like the uniform 1 float, and then we kind of did like some pointer arithmetic to copy over each value to the memory. Yeah, and so a lot of our testing, we were not having a lot of luck using the tickle scripts or anything to try and simulate cache. So we ended up trying to use the ILA and set up triggers to like see what was going on here. So this is a screenshot. We have it set up to look at like the input vertex to the shader core and the output vertex, and then also our memory streams. So this one doesn't show any memory accesses in it, I think, but we were getting kind of at the beginning of the program when it would start. We had a lot of instruction reads where it's loading into the cache, and we went through those and compared them with like the output from, what is it, like GLSC test or something like that. And so all the instructions were being loaded in properly, and then I also saw some of the uniforms being loaded in kind of at the beginning, and I wasn't seeing memory reads after that. So that's why we kind of think there was a caching issue. But then also in this picture, kind of late last night, we noticed like this T-last signal down here that's being propagated out is held high.
So I think all those things are T-last.
Yeah, so that's something where we have to check and fix, I believe. And it could explain some of the errors we were having. But that's kind of our main testing that we did to figure out what was going on. Yeah, I guess I might show the demo video before that one. So this was our color wheel. We had it working at the end of MP2, and then with this, I think this might be because of T-Last.
T-Last, yeah.
We had some really weird,
Pretty
like,
cool, sure,
yeah,
yeah. It's kind of making an extra triangle from the end of the strip.
yeah. And then the main triangle is like not colored, which was weird. But I kind of like that it stretches out those triangles. Yeah, and then our shifter triangle is just like sitting in the middle there.
But it's a different size than groups or was it the same size as what you showed us? About the same.
I think it's about the same. So, yeah, I think we might try changing some of the scaling values and see if it.
Just hard code it
Starts
again
to
in software and
fit,
see
yeah.
if it's twice the size or something. And that's a pretty good confirmation. Well, both. Do them separately. You can just shift it so that confirms your addition is working, and then scale it to confirm your multiplication is working, and then you can hyper focus on the cache.
Yeah, so some of our big challenges was a lot of the time we were debugging, there was just like nothing appearing on the screen. So that's where I think we ended up also having where the Y values were all just being set to 0. So like all the vertices were on the, maximum or minimum of the screen, and we just couldn't see anything. But then when we tested with the ILA, there was stuff going through, which was kind of nice to find out. But the problem for a long time was our insert instruction. I read the ISA wrong, and it was not inserting like B0 into the lane. It was inserting like B0, B1, B2, B3.
It's just a single value at a time. Yeah.
Yeah.
That was also a debatable design decision, but that's all.
So, yeah, so the insert was kind of messing with us for a long time last week. And then after that, we started seeing triangles again, which was nice.
So it is interesting, you have the ILA, you can see the value, you can see vertices coming out, but just seeing ones and zeros isn't really enough. Then you have to go back, and I don't have a good system for that other than maybe write a little script that says, okay, here's this really long hex string, convert it back to X, Y, Z and RGB values, and then you'd have a better feel for if something weird was happening with those values.
But the Y was easy to tell because it was just all zeros.
It's all zeros.
So.
Then you do something.
Yeah, and so we kind of we felt like there was a lot of difficulty debugging this one just because we kind of knew what was happening going in and going out, but there's supposed to be a lot going on kind of in the middle that we didn't really have a lot of insight to what it was actually doing.
Did you try FlexSteel, the application?
We did, and it crashed Gotham's computer.
I once had to go physically power cycle one of the Xilinx computers, which should never really happen, right? I mean, it just sent the data over to Ethernet, it shouldn't, and it locked up, it wouldn't recover, so. Cool.
Yeah, that happened too last night, but I think that's all we have.
You're obviously very close. I think it's totally fine, tomorrow, hang out with Will and Brandon and just kind of commiserate. They look like they have a valid T-Last valid solution that you can kind of look at the cache issues as well. You'll need to get it working, for MP4 anyway. So you might as well just kind of, between the four of you, I think have a solution that should be going forward for MP4. Okay, great work. All right, group 2, come on.
All right, so we're group 2. Wait.
You can go to the next one, sure. Maybe just
Sorry.
somewhere on the screen.
Oh God. Oh,
There we go.
there we go. So I'm Long. I did mostly the driver code, did some the shader bug fixes.
So I did the OpenGL application and I did some of the shader stuff for like the Vertex shader.
I wrote comments for shader core as well as tickle test bench this time for that, to verify whether those instructions are working.
Yeah, mostly did hardware. Just work with the IC and the channel in general, and helped with the driver code and channel boot.
Okay. It's funny though how you describe everyone describes their contributions differently. So all of that is either hardware or software, right, ultimately for this, but, okay.
So, shader, I'll show.
So Vertex
Sci-fi.
shader core is like I started with writing all the instructions which are in the pre-lab, so that since we have already pre-lab instructions too, I verified that pre-lab instructions whichever I wrote with the pre-lab instruction values given. So first I worked on all the pre-lab instructions, and then Joe started with the pending instructions, remaining instructions which are not there in the pre-lab. So if you see, like for load we have like these are for load, and after the instruction get executed, it will go through LE2 and will go first to fetch the next instruction. Whereas for the load instruction, it needs to go with an extra state. Whereas store needs to go from an extra state and then to the fetch. So ideal thing it and then wait for the next vertex. So that's how.
And what you did differently than what now teams did is you move some of the code into a procedural, put it in a package, and that kind of helped clean up the Vertex shader core file a little bit and made it easier to test.
Is that an example of that? Because I can't tell.
Yeah.
Wow,
Yeah.
that's on me, I can't. I believe you. Maybe why don't you walk through it, so, a for loop of some sort.
So yeah, that's for the
Okay.
procedural for the shift right. And so it's in a procedural in a separate file, so it's easier to test that way. And you pass in an array of each of the Vertex values, so then you can just loop through them, shift it them out that needs to be.
And that's interesting, I mean, it's a totally valid approach. It looks like you're doing a lot of like manual bit manipulation there, whereas those other type packages may have made that last line a little bit easier to grok. But that approach of being, you know, very behavioral, kind of treating hardware design as another just software development process, can be very, very effective. I think ultimately you still need to understand intuitively what's happening in hardware, so you need to have that mental model of what's happening underneath the hood to be effective at it. But you can start to basically ignore HDL entirely and just write software and just have the tools kind of convert it, because it should have, even though it looks wrong, and you may take a VHDL class and say, no, you can't do that, but you can, and the tools are pretty good at inferring the same kind of logic that otherwise you would have just inside a state machine otherwise.
Oh, is this for driver?
Yeah.
Oh, okay. So driver changes. Mostly pretty straightforward. The uniform and the uniform matrix. It took a little bit of work to understand how it was indexed, like how each vertex array or matrix was getting into the driver, and in this indexing those. Base address, graphics map, address mapping. It's again
So what's in
pretty
this,
straightforward.
why don't you describe what's in this screenshot? Because I see, this is,
So that screenshot
That's the
is
shader.
from the shader.
Yeah.
okay.
So it was kind of in par with the driver change, so I threw it in there. But what it basically was doing, it was testing a lot of the hardware stuff. So like V color was the only output that we had. I'm going to use the cursor just for everybody's
Sure,
sanity. And so I did a lot of the testing, quote unquote testing, here for the shader. So like there's a swizzle command that's happening after it gets the color. That way the adds checked, multiplies checked, and then I clamp them, get the maximum between a range and get the minimum between a range for, I think it was the start and the last, one way or another, so that the colors would come out differently, but certain areas would be brighter than others, and other parts would be darker. And I have a screenshot later on, the software version of how I tested that.
That's very nice. The only counter suggestion I would have made if we had talked about this, I like that you did this, would be just kind of have one shader that isolates each instruction. So this is a shader that just tests clamp instruction, and this is a shader that just tests multiplication, and then you should have like a, then it's back to a software approach where you always have like a regression test of we've changed something in hardware, we run all these, we see which instruction is clearly
Yeah,
broken
and
out.
I tested them one by one before I did this,
Before you added them all
so
together.
I was able to do that, and I thought about putting them all on their own, but I wasn't confident in my own ability to find a way to get that to work on the software end with just changing the path names.
Oh, I see, yeah, well, and I think also,
Or getting it in the right place.
yeah, and naming the files becomes important, and you then still have to have like a meaningful demo that like uses all those instructions and does something that, for us at least, that we can visually check, gives us the right result. But that's the right approach, I think, to take for adding a new instruction. Let's change one thing, confirm what changes in the driver, and then you can just test hardware at that point.
Testing,
More testing.
more testing.
So for testing, I wrote the TCL script at the core level, just for the core module. So this was like last time I used to write VHDL test benches, but this time I started using TCL script and it was very easy compared to the TCL test bench.
So what are some of the asserts you have down there?
So this test bench is written by Joe for the other instructions which Joe has written. So
Yes, let's just test out those procedures that we had in the ISA, and first you can have a list of inputs. You put each of those inputs into procedure, then you can have a list of outputs that you compare it to. So all of you just run this test bench. If it finishes, it's good, and only fails when one of those comparisons fails. So makes it like fast and easy to just make sure it still works if you change anything.
Right, but I find personally, I think we can have a good conversation, but test-driven development for hardware I find very difficult, just personally, because you almost have to design the whole thing in software first, because otherwise you have, I think, the issue of, okay, you wrote the test, but how confident are you that the actual result of that test is correct, or is it just based on your own like personal understanding of what the result of that test should be? So you can pass every one of your tests and still have the hardware be wrong, in a sense.
And for this, I just manually typed in the outputs I was expecting, so it's a lot of work to get that expected output. But
So you yourself were like the behavioral model of your own brain was the
Yeah.
behavioral model of the hardware that you were testing against. That's kind of how I do it as well, but I think that's also kind of a flawed approach, right? Where you're only as good as your test vectors, but you yourself are generating and having to generate. But this is nice. Did this help find bugs early in the process, or by the time you wrote this, you kind of
I
knew
did
this?
find one which just had like the wrong index value, so that
Bugs? Oh yeah, so here are a bunch of our bugs. The color wheel there, that's an issue with our T-last. We also have a problem in our driver code where we're not flushing the cache properly.
And so the two of the circles that are up there are software related. It's not hardware, but I thought they were kind of fun. So this was the first approach I did. So if you remember my first iteration of this from MP1, I just changed a bunch of things to get it to work. This was still in pixels, but with a shader
Or
applied.
like GL points, you mean?
Yeah,
Okay.
yeah, but with a shader. So it looks like a nice little galaxy. And then this one was me playing with the shader more, and I put it in the triangle fan this time. And so they came out darker because I was still playing with things. But yeah, and that was partially because like this one I forgot to change the primitive type. And then I also had problems with the uniform, just because I couldn't figure out where I needed to put them for a while.
Can you talk about triangle fan yet?
No, I have not.
Okay. We get
It won't look very 3D even with a triangle fan. You would need a lot of triangle fans for it to look 3D. We'll get to that point.
Yeah, there's another error for triangle fan that we were trying to solve. So it worked great on software, but there was a bug in our hardware. We're not sure
Seems
where.
like another team that needs to kind of learn about the T-last fix, which again, that I feel like that driver solution, which is also tell this module how many vertices there are, is and you would do that at GL draw race calls when you would update that. It feels like it's almost like cheating, but it's fine, it works. And so otherwise vertex fetch should generate the T-last signal that this module should be able to see and latch onto and then just regenerate it in the output vertex. But that driver approach just works. So.
Yeah, so for
we did fix the T-last issue because the code gave us it was going out once every frame. We wanted after each primitive, so we just basically latched onto the T-last from the vortex fetch and passed that through. So this code does actually work now. which is bogus.
We probably just have to change it on the driver's side. Just checking for that. Is this our? Do we play this?
It's on the video. Okay.
Because that doesn't
Oh,
even
wait.
video, so.
Plus sign on that.
Okay, MP2 is back to its original state, which is good progress, I think. Does it move when you're triangle as of yet? Problem caching still, I think. You have some nice little
Yeah, that's from software.
the software sphere.
Yeah, I wanted some kind of result to kind of show that OpenGL worked. So yeah,
Tried to do
that
some gradients with that.
I did try to get the gradients working, and it kind of looks really nice. That's actually, I had a problem for a while where it was another TLAS issue that I needed to figure out, but it was on the software end with draw arrays where I needed to put a for loop to get those two spheres. And if you overlap them, because it still randomly picks a location, so if they overlap, there's a problem with coloring, so they kind of mix. But that's apparently an issue for MP4.
With how to blend things together or how to deal with depth. Yeah, and so let's talk about, MP4 just briefly. It seems like, a few groups, there's a little bit more technical depth to catch up with this. You're not going to enjoy that part of MP4 if you don't have this part of MP3 working, because it's really just more of the same of, now you have a second shader core, it's running effectively the same ISA, you got to get it working. You might as well stay on the MP3 code base and just continue to get that to work. But separate from that in MP3 are the other render output things to add to it. That's the depth buffer, that's the alpha blending. That can be you can peel off a person from your team and have them just get started to work on that. Because that's kind of independent, that you can test with red triangle again, or two triangles, and confirm that you have two intersecting triangles, or two blended triangles. That's kind of sufficient to show that that part is working, and then hopefully it all comes together and you can write an application that shows it all working. With alpha blending, I think we talked about it briefly in class, there's actually a lot of possible permutations of how you can blend things. And the MP4 document just says, and my advice is, just pick a few and just show that you have it working. Because yes, you could always write an even bigger state machine or an even bigger case statement, but you don't have to for this. So just get a few examples working, and that should be sufficient for MP4. Any questions for this group? All right, a little work to do, but I think you're going to get it. So good job. All right. Last but not least. Oh yeah, got them. They threw you under the bus. They said we were going to get this all working, but you didn't come. All right. Hardware plus software. Aiden did the entire process.
I did that a good chunk of it over break, yeah. Okay, so our Vertex shader core, it is pretty much the same as the other groups. I said out vertex skips, right? It's supposed to be out FIFO. I didn't get a divider implemented, which would have been nice, but not quite. And then, I also had some issues with, I think it was with, I had some issues with out FIFO where, because it skips the write stage, I incremented PC and write, but I didn't go to write without FIFO, so I got nothing for a little bit because it just wasn't incrementing PC.
All that to save one cycle anyway, right? So with that.
That was a fun bug to fix. Just had to stare at the ILA. Okay, so driver changes, num vertex, that definitely matters. If you don't have num vertex, then you'll get fun color wheels like that. At least I did. I think the bug's gonna differ based on everyone's primitive assembly implementation. But I think that's why a lot of people are having the triangles that were kind of like overlapping. And mine was really fun. I don't have a picture of it, but it was like flat. It was doing like all the permutations of the triangles. So
Was it shifting then, basically? Or
yeah, it was shifting. When it was like like 4, it just did all the permutations, which was neat. Cache flushing, that was a fun one. I was dealing with cache flushing while the multiplier also didn't work, which was actually causing it to crash. So when I was flushing the cache, then it crashed, which I thought was a bad thing, but that's because it was actually working correctly because multiplier was doing unsigned multiplication, which caused some overflows in later components and caused it to stop working. But that was really fun to fix. When I set the invalidate bit, it didn't do anything. So I had to flush it. I
think
think
invalidate again is for, I actually, so I guess I don't know. But I thought most teams had flushing working in MP1, right? Or no, I remember seeing too many glitchy things in MP, or certainly in MP2, where like you would see the whole triangle. So I thought, in render output, there's a decache that you flush, right? So I kind of thought you could just kind of use that same logic you had from render output to get the flushing to work. I know you got it to work,
but I thought I could go even faster because invalidating is probably faster than flushing, in my opinion. And then
invalidate should just be setting a single bit, right? I mean, so that should be correct. So
yeah,
it
it should
be
just
setting
set
a
all the
valid
valid
bit, I would think.
You don't have to write back and stuff.
But does it have to invalidate the entire cache? Is there a way you can invalidate a particular address?
I haven't seen a way to do that in our cache interface. Init with cache variables. What does that mean? Why did I write that? Okay. We got the. Does this video even work? It does. We got that fun bug too. I like that one.
Now, it looks obvious when you do it in TriPaint, right? So to me, yes, it's obvious that you can, I guess only students who've taken this class, it's obvious what's exactly happening with that. But if you weren't using TriPaint, how would you catch it? Where the triangles just,
They're black.
they were just black, always color was wrong, and they were always in the wrong place, I guess, by default, if it was a red triangle. I feel like teams got a little lucky, because I think there'd be color values that would correspond to, if it was all red, right, wouldn't all the values be off the screen then, for it to be like 1.0 or 0.99 or what have you, so.
Yeah.
A little bit of luck, but that's great. It's a really nice visualization of the bug.
I want to go to the next section. Okay, testing infrastructure. So I wrote a TCL script that that mimicked how the cache would work. And I only tested the core. I didn't test anything outside of it. It worked good enough, I think, to just see if it basically worked before I synthesized it. I should have tested it more in depth, and the test probably worked better than I thought they did for a lot of the debugging. I just didn't look at the simulations hard enough. So that was one of the issues. ILA.
It's also a mindset issue, I think.
Yeah.
When you have a design that, let's say, is 95% working, it may feel like you're going backwards. Okay, now let me adapt this test bench and this testing methodology to kind of simulate my results. When you know it's close, let's just do one more ILA run, let's just run one more bit file. It may still be worth, for teams now that we're on not as much of a pressure of a deadline, to peel off one person and say, okay, take another look at those scripts and see if you can get them working, with our existing tool flow. That may save time, for MP4 for your project.
So I did a lot of testing on the ILA. It was useful to pick out some issues, specifically the cache ones, because I could see if I was writing back or not. So I hooked it up to the memory buses. Oh yeah, I had print statements in my driver, so they didn't do anything. Is the seal emoji not showing up? Oh my god, so sad. Okay. Okay, so we got it working.
That looks wonderful.
Don't
This
mind.
perspective's still off, right? You can see that, right?
Yeah, it's because of reasons. That's next lab, right?
Yep.
Okay. Depth buffer is not implemented. And then.
You can kind of see it. Maybe
Yeah, you can kind of see it if you try hard enough. It'll get wider at some point. There you go. I took a video at a bad time. Yeah, I had to switch it to orthographic so I could actually get an output. Otherwise, it was just big because no division.
Awesome.
That's it, yeah.
You kept your sanity intact during this lab, I hope. I'm worried for you.
Of course I did.
Okay. One good night's sleep is all it takes. Yeah, other slides or is that?
I think that's it. Yeah. Yeah.
Any questions for the team?
Yeah.
So back in your driver code, when you talked about the number text, you had to change anything in hardware as well, like the propagate signal, TLAS signal?
No, it was just, it hooked up right, I think.
And if you don't mind humoring me, if you go back to the first team or group of four should go all the way back to like slide 3 in this slide deck.
Can't hold it.
No, you may have to do the arrow in the lower left-hand corner down there. Because it'll mess up with all this stuff. Keep going. Keep going. Here, right, yeah, that one. I recall now something I maybe should have mentioned, because I do believe you should be able to pass through TLAST, but this is how the hardware was set up. That last command down there in the driver, the top level vertex shader is already set up to assume that it's going to receive enough vertex and set TLAST accordingly. What does it do if you don't set that value? Possibly it sets TLAST every time, I don't know, or it never sets TLAST, possibly is what it does.
I think it sets TLAST every time because I have drawing a bunch of triangles. So I think that's what that would do.
Because if you're just doing GL triangles, primitive assembly doesn't care, I guess, right, about TLAST. It doesn't check. If it's just GL triangles, that depending on how you implement it, your state machine doesn't even look at the it just keeps taking the next 3 and calling it another triangle. Or if it does check, it doesn't matter because it assumes the same primitive type. So maybe I should have called that out. I'll have to look at the writing for the MP3 document. But that hardware logic, which isn't shown here, to take that counter into account and generate TLAST, I believe is already in place. And you just had to write that call to the driver to generate TLAST, or to generate the count value for TLAST. Other questions from the team? All right, way to go. Very cool cube. What did the seal look like when you tried it?
I didn't really get any output. So.
Okay. It also crashed his computer.
I ran for a few minutes and then I stopped.
Let it go. Okay. All right. Everyone looks a little tired, a little burnt out at this point. I get it. So that was a tough lab. I don't know if waiting a couple more days would have made that much of a difference. So the nice thing in some sense about MP4 is it does have these kind of discrete components to it, in that part of it is getting a fragment shader to work. I would argue that until your team feels really good about the MP3 vertex shader, you keep working on that. It's not wasted effort. It's kind of like a porting task once you have it working. Then there's the other aspects of MP4, the depth buffer, the alpha buffer, alpha blending. I think it's manageable, it's doable, it's looking at render output. You do need to have some version where you're passing triangles through successfully to be able to test that. A team tried it, but another thing to implement potentially, and you could do it via the driver, would be to add another register, which would be in the top level of the vertex shader, which says, if this register value is high or is it this certain value, just don't do any vertex shading at all. Just ignore it all. Just pass output axis stream from input axis stream. And you could be clever and check if it's pass-through.vert or something, but don't even be clever. Just have it something you separately set for testing purposes where you want to get MP2 code base back up and running so you can start to look at MP4 in parallel to getting the rest of MP3 working. Don't feel that not having the perfect triangle flyby shapeshifter working is a blocker for MP4. It shouldn't have to be. Don't also feel you have to delete the MP4 stuff. You should be able to just implement a hardware pass-through, ideally via some driver-controlled thing, or just wire it up so that it's a pass-through until you get the rest of it working. And then in parallel, work on the other aspects of MP4. Every team has at least 3 members, at least, in theory, contributing to these. Split up the work however you feel best. If everyone feels best just sitting in a computer and working in parallel, that is fine. But then don't forget the project proposals as well. As you hit bit file build, that's a good 15 minutes to talk about the project at that point and think about things. Please don't just wing it. Okay, think about it, ask questions. What will be a valid project idea? What is a reasonable student-driven idea for what could be an MP5 type thing, and make it feasible, because you know that there's just challenges with really low-level stuff, even when at the big picture everything makes a lot of sense of what you're trying to do. Otherwise, my strong suggestion is to get a good night's sleep. Yep, there we go. And rest up, and please come back on Thursday. We're going to start talking about viewing and transformations from kind of the algebraic perspective, and I think a lot of what we're doing here will start to make a lot more sense in terms of perspective and orthographic views and things like that. Let's leave things here for today, and let's push hard on MP4 and the project, and I think you'll be happy with the final outcome at the end of the semester. Thanks.